This is TPS setup on an ST2. The airbox is already out because you can't do it with the airbox in, even though these airboxes are really annoying to get in and out. The TPS is on the left hand side here, and you can see there the screws. Oh, torch just died. You can see the screws have the paint in them still, so we would expect this TPS to be wrong. Like the ST4S, which turned out to be okay, but I would expect it to be wrong. On this there is your air bleed screw there. That's the vertical air bleed screw. If we go into the other side, at the back here is the horizontal air bleed screw. This is your throttle wheel here. Down below is the fast idle setup, which is that there. On top, get myself out of the light, we can see the left hand throttle body stop screw. And this is the reason we're sort of pulling the airbox out. We need to get to that. This here is the balance screw, which if we open the throttle up, you can see the balance mechanism there. We will adjust that as part of the procedure to make sure that the right hand throttle body isn't impacting what's happening on the left. The left hand throttle stop screw is just here, and we'll be winding that out and pretty much wind that out, and it won't go back in to have an effect. I'll wind it back in as much as so this throttle body can't jam shut, but I won't wind it in and use it as any sort of setting, because this is the master setting over here on the left hand stop, and then the balance setting specifies where this throttle body is here. To start with, I'm just going to clean the throttle bodies. This bike's done nearly 80,000 Ks, and these are quite clean, so they might have been cleaned before, but I'll just give them a quick clean out, and then I'll pull the air bleeds out. I'll wind them in to work out how far they were out from fully closed, and then I'll take them out and I'll spray some cleaner in there. I tend to use this cleaner a bit, the 3-bond engine conditioner. It's good at getting rid of gummed up fuel deposits. It's good for carb jets, that sort of stuff. So I'll just wind the air bleed out. Well, first I'll wind it in to see how far out it was. If we go, it is half one, so it's one turn out. So I'll just wind it all the way out. So it comes loose. Pull it out, and you get that. That's your air bleed. It's fairly clean. Somebody may have been in here cleaning it out, but I'll just give it a quick spray in there, give that a wipe. And that's just the best way to make sure that everything in there is clean. The air bleed on this side is just there. So we'll wind it in, half, one. So they're both one turns out. Usually when I see things that are both the same, it makes me suspicious that someone's just set them the same because they think they should be the same, whereas it's just not. That one's still fairly clean. It's really not any relevance at all having them the same, particularly when you're using the gas analyzer to set the idle mixture. The actual air bleed setting is just whatever it ends up needing. As I sort of keep saying, you just give it what it wants. That's how air bleeds out. We'll just give the throttle bodies a clean. Usually these are just a rag and brake clean. Get your finger down in there and wipe up as much as the gunge as you can. So do the edges of the throttle blades as well. And this just sort of ensures that there's nothing blocking, and the actual gunge can also have quite an impact on the amount of air that can get past at times. Get into the vertical cylinder. Okay, so we'll call them clean. Things to do is unhook the throttle cable off the cable wheel here on the right hand end. So just take the throttle cable off, so that way there's no hold up from the throttle. The right hand or horizontal throttle stop screw, just there. We'll knock the paint out of it. Just using a long 2.5mm T-handle. Jam it in, and then it's tight. Half, 1, half, 2, half, 3. More than enough. And the balance screw, which is down here, we'll wind it up. We'll wind it out, so that way we can close the throttle on the right hand side, sorry, the left hand side, without the right hand side interacting. So I'll wind it out and usually just go a set amount of turns. So I'll go half, 1, half, lost it, 2, half, 3. I think that was 3 turns. And now you can see it's on this stop here, and the right hand throttle body you can do that with. So that means the left hand one will be allowed to fully shut when we wind that screw there out. Before I touch this screw, I always measure where the TPS was. This is the TPS connector here, and we'll just pop it out. Now the way I measure the voltage is with a little jumper box, which again is something that not many other people would have. You can also do this by simply back probing this connector. You get paper clips or something and push them down the back, or you can take the ECU connector apart and get into it that way. This wiring loom, I think, is blocking me getting in there. There we go, that's in. Let me pop that one on. That's our little block. And grab the multimeter and pop it in there. Make sure you don't touch them on the bike anywhere. So multimeter on. If we turn the bike on, we'll get our voltage. 467 millivolts, and it should go about 4.8. That's about right. So there might be some paint in here. I'll just dig that out. Oh, 2.5mm. From the front, again push in through the paint, and we start winding it out. Half, 1, half, 2, half, 3. And you can see the gap there is nice and big. And we're down to 163 millivolts. We give it a snap shut at a 122. So that's what I do now, and I usually just put my fingers in the bottom here and just give it a bit of a push on the low side and just see what it gets down to. Sometimes with a few snaps you might find you get them down a bit lower, but it looks like 114 is about as low as it's going to go. And sometimes you can even wobble the shafts a bit, and just with the free play in the shaft you can get it a little bit lower. But that's just an indication. So 110. We're after 150, so it's definitely low, so we need to adjust it. On the side of our TPS, we can see the 2 screws. They're a T20 hex. They're usually not Loctited in. Some of the late ones might have a encapsulated Loctite on them, I don't recall. But just be gentle. Had one break last week that was corroded in on a 998, and that's not fun drilling them out. So we'll loosen these off. Just Ocky straps the hose out of the way. Just push the T20 in through the paint, and there we go. You can tell this is a non-linear TPS by the fact that it has these plates, and underneath these plates are slots. The linear TPSs don't have plates and they just have holes, and that's because you can't adjust them. That's the whole theory with a linear TPS. You put it on, screw it down, you do an electronic reset via the ECU. You don't do this. And likewise, you don't do electronic reset with a non-linear. Okay, so now it's loose, and we just start moving it. You can see you can move it, rotate it. It's a bit hard to rotate it with all the stuff hooked up, but you can see the rotation and the slots. So I'll plug you back into the top. Now, I'll just start adjusting. So we're going for 150 millivolts. Just make sure the throttle is nice and shut. And which way do we need to go? That way a bit. It is quite sensitive. You might be surprised by how sensitive it is, and it can move when you tighten it up. So you just need to watch your numbers and be as adaptable as required. See, this one's dropping a bit when you tighten it up. Tighten this side up, we've got 150. Don't go too tight in the little screws. Now open and close a couple of times. See where we are. 158. You don't need to get 100% on 150. Between 150 and 160 is sort of where I'd be happy. You can sort of loosen one screw off a bit and load it a bit with your finger and then tighten it up again, and it might move a little bit. Make sure it's sharp. So 155, I'm going to call it quits at that. I'm happy with 155. Just make sure the screws are nipped up. What I do now is I mark the screws with a different paint colour, and that way I know if I look at the bike again that I've adjusted it. Brake clean to take the 20, I think this is a 98, 23 years of dirt off. So just put some paint on the heads of the screws. Might be liberal, no need to conserve paint. And it also lets me know if someone brings the bike back and says, oh, it runs funny, and you can tell they've been playing with it. If the paint's gone, because the colour I use is not a colour that anyone will probably have access to. It's a BMW little touch-up bottle of something a bit unusual. Okay, so now we've done that. What we need to do is wind the idle stop in. And the idle setting on these, I think, is about 2.3 degrees, but I better go and check that. So we're winding this in, and I'll stop there. So I went to hook up the diagnostic tool to talk to it to read the throttle angle, and it wouldn't work. And then I realised it has an Ultimap EEPROM in it, and that's the problem. The Ultimap EEPROMs don't talk to the Morelli style diagnostic tools. You need an Ultimap diagnostic tool to talk to it. So what I usually do is pop that EEPROM out and put something from a 1.6M in it. This is a 1.6M ECU. That's what a 1.6M looks like, rounding on top. Happen to have a 067 ST2 EEPROM here to put in, but any 1.6M EEPROM will suffice. You just need to be able to turn the key on and have the TPS output interpreted correctly by the ECU, so you can then set the throttle angle using the diagnostic tool. So now we have a Morelli based EEPROM in it, so it talks to the diagnostic tool. In this instance, again, using the Texa Axoni, because it's easy. Most of you will probably be using Gutsi Diag, which is PC based and not so easy to hold in my hand and talk about doing this. So the throttle opening for these is specified as 404 millivolts or 2.4 degrees. Now I always go by the degree setting on the Axone. We can read it. It currently says 2.8 at 450. So I'll just wind it back until I get 2.4. And often this doesn't actually give you even numbers. So it's giving me 2.5 or 2.3. It's 2.5. Take it out a touch, we get 2.3. So 2.4 is, I guess, where it changes from 2.3 to 2.5. So say about 394 millivolts, which is pretty close to the original, to the 404 spec. Often they're not quite that close, but I always go by the degrees, and we're seeing 2.5 there. So we'll call that set. Now once I've set that, I've also put a bit of paint on that one. So once again, mainly I can tell if someone's been playing with it. Okay, paint on that. Now I'll adjust the stop here on the right hand throttle body, and we just don't want it to jam. So I'll turn the multimeter off now because we're done with it and unplug it. So get the 2.5mm hex. I'm going to wind it in until I just see it pushing the throttle blade open. And when I'm happy that the throttle blade can't jam, that's just it, just there, it's moving now. I'm happy that it can't jam, that's fine. And so we wound the balance adjuster out 3 turns. So it has to go back in 3 turns. It might not be correct, but that's just where we're going to start, just for consistency's sake, I guess, or continuity. So 1, 2, 3. I think that's about where it was. I can always look at the video later and see how wrong I am. I'll clean this off. Put a bit of paint on there as well. So now we've got TPS set, tightened up, idle stop set, balance is back where it was, I think, and we'll deal with that when we get it running. I always put the airbox back in before I start running these. It is a bit of a nightmare to get the airboxes in and out of these ones, particularly this rubber that goes on here. This bit, getting it back into the airbox and is quite frustrating, but that's all part of the fun. I'll put the original EEPROM back in the ECU, and then when I get it running, I don't need to use the Axone on these. The idle mixture setup is mechanical. It's a trim pot in the ECU itself, so we don't need a diagnostic tool as such anymore to really look at anything. One thing I'll look at very quickly is the fast idle. The fast idle cable comes in here, and you can see this actuating arm here has a slot in it and a pin inside it, and that sort of defines the endpoints. There's no point trying to adjust the fast idle with the cable here, because that's not what you're trying to do. You're meant to have this arm set up so the cable lets it move between the 2 endpoints, and that's fine. The actual adjustment is this screw up here, which we can sort of see there. That's the screw that adjusts how much fast idle you get. So if you want to increase the fast idle or decrease it, you adjust this screw up here. Just make sure you get full travel on the slots and start adjusting this screw, which you can probably see a bit better from the top, maybe, or maybe not. That screw just there. And don't forget, once it's done, hook the cable back up. Now that I've hooked the cable back up, because we've changed the throttle position, or we've changed the relationship between the TPS output and the butterflies, sometimes you find that the throttle is more closed than it was before, because it was 110 to 467 millivolts opening. Now it's 155 to 390, so it's open less. And what can happen is that can take your throttle clearance out. So what I'm going to have to do now is just increase the throttle free plate, and possibly once I've adjusted the balance, when it's running later in here, I may need to do it again. But it's just one thing to be aware of. It's almost all the way in there, but it's wound out a lot at the handlebar, which I'm not sure if we can see up in here. So I'll just wind that in a bit to give us some free play, and then adjust as required again later. One other point worth mentioning is that when you're doing this, the ignition is turned on for quite a long time. And so if you have a headlights on model, it's often worth pulling the headlight fuse. That way the headlight won't flatten the battery. I usually do that. One thing you can do when you've got a diagnostic tool on it, and while I've got the original EEPROM in it, is just go through and see if it's got any faults stored. This one had a throttle sensor fault, which it always does when you take it back to the minimum. It will always log a fault then. So just clear it out. But just check all the inputs and make sure they're valid. So we've got 740 millimeters of mercury air pressure, which is about right. 14 degrees air temp and engine temp. So they're both the same, which is good. That's what you want. TPS is now showing 3.2 degrees. It's a bit wacky. It's doing that. It did this to me the other day. What if the Axoni's being weird? You can see the throttle position vary when I pull the fast idle on and push it off again. That's what you expect to see. I think it is way out of balance, is our problem. Just going to adjust the balance out a bit, because it looks like it is a long way off. It's screwed a long way in. So wound it out. Turn. That's 2.5. So I think so I took a turn out of the balance adjustment, and now the throttle's showing 2.5. So that sort of shows you how much out of balance it probably was, because the right hand idle stop, which is what it would have been sitting on here, is only wound in enough to just crack the throttle open. And so it was sitting on this stop with the balance adjusted, and now it's possibly a bit closer to the middle position, but it'll be interesting when I start up to see just how far it is out of balance.